Okay, so starting the detailed section of chapter 9. So first question is a ray of light passing through a length of curved optical fiber. Draw a diagram showing the fiber and the path of the ray of light. So they are talking about the optical fiber, and we know that optical fiber is the application of total internal reflection, right? So we have according to the reference with the reference of total internal reflection. So let's suppose for optical fiber, we have a curved optical fiber over here, and we have to reflect light internally in optical fiber. And for reflection, we know that the incidence is equals to angle of reflection, right?
Yes.
So let's suppose if light is moving with certain angle. So let's suppose the normal line is over here. So you can easily measure incidence from here. Just estimate it. We don't need to calculate the calculated angle or the accurate angle over here. We just need to draw a diagram over here. With help of normal, we get the second ray or the reflected ray in optical fiber. In this diagram, see that both wave was same, and this is the diagram for optical fiber. Now complete the remaining part, right? So this is the diagram for optical. And second part, describe one use of optical fibers in medicine. You
It
may,
helps to use the internal.
so the device or the name of device is known as endoscope, right? So you may also draw a diagram. So that is not compulsory. It's up to you if you want to draw a diagram. So you may also draw a diagram. Otherwise, you just need to describe use of optical fiber in medicine. So we know that first of all you need to write the name of the device is endoscope. And secondly, we know that to observe internal organ, we use to diagnose the purpose of application of endoscope. Okay, and all explanation is already written in our notebook or in the textbook. So you may need any use or multiple use of endoscope, right? Part B,
It's 3 times 10 to the power 8.
for light, we know that is 3 into 10 to the power 8. And for
It's the same for microwaves.
same for microwave because microwaves are electromagnetic.
And steel is 6,000.
Yes, the speed of sound in steel is equals to 6,000. Okay, so these are the identification because the speed of sound in solid is around 5,000 to 6,000, the approximate value, and the refractive for block. of glass is 1.5. Use your value for speed of light from B to calculate the speed of light in the block.
So it would be speed of light in vacuum divided by speed of light in medium.
Yes, so already have a value of refractive index, right? So this is the refractive index, and use your value for the speed of light from B to calculate the speed of light in this block. Yes, so we already have the value of the speed of light in medium, sorry, in air, and for the speed of light in medium. So what is the formula? Is equals to speed of light in divided by,
Speed of light in the medium.
yes, we just need to calculate or just need to compare the value. So that will give you the answer, right?
Yes, it's 200 million.
200.
I'll write it in standard form.
Okay, because we already have the value of the refractive index, and we just need to find out the value of speed of light in medium.
It's 2 times 10 to the power 8.
So this is the value of speed of light in medium, right?
Yes.
Okay, because we know that this side we have value 1.5, value the unknown, or in short, so write it as N over V, or V is equals to over. Okay, so next question, what is meant by total internal reflection?
It's when light reflects to a certain degree when it.
Yes. So we know that when angle of, you just need to remember the condition of total internal reflection. So that will help you to write the definition of total internal reflection also, right? So basically for a total internal reflection, light travels from dense to rare, and it also reflect back in the same medium, right?
Yes.
So light ray, reflection of light ray, same medium or in the same dense medium, where there is no, right? You know, there is refractive are going to be reflect with the same angle, the same medium, right? And that is dense medium. And what about the critical angle?
It's when the incident
Yes, the
angle of incidence is greater.
critical angle is that at which light is going to be refracted by 90 degrees, right?
Yes.
The angle of incidence is basically the angle of I to her refracts at degrees, right? Okay, so next part. Figure 7.1 shows a ray of light traveling in air incident on a glass prism. So light ray is entering into the glass prism and the speed of light in air is 3 into 10 to the power 8. The speed in glass is 2 into 10 to the power 8 meter per second. Calculate the refractive index of the glass. So that is also simple. We just need to solve with the reference of same formula we already done equals
It's
to,
giving me 1.5.
yes, because we already solved the same question with same values. So answer will be equal to 1. So 1.5 refractive index and show that the critical angle for the glass air boundary is 42. So we need to show that the angle of angle critical angle is 40. So what is the formula to calculate the critical angle? Do you remember the
Sine I over sine R?
yes, we need to calculate with the reference of speed of light. So formula will be equal to, now we only have to calculate the critical angle, right? And we know that at critical angle, light will bend at 90 degrees. So refracted angle will be equal to 90, sine 90 will be equal to 1. So that's why we used to calculate with the reference of n is equals to 1 over sine c, right? Because if you remember the original formula, so original formula will be like this, equals to sine r over sine I. Because when r moves from dense to rare, this formula is related dense to rare. And when we are talking about total reflection, light ray is moving from dense to rare medium. So that will be equal to sine r over sine I. And we know that at critical angle, sine r will be equal to 90 degrees and sine 90 will be equal to 1. So that's why 1 over that is I. And we know that critical angle, angle of incidence will be equal to the critical angle. So that's why n is equals to 1 over sine c. So that's why we use this formula to calculate the critical angle. So that will be equal to n equals to 1 over sine c. And we already know the value of n, that is 1.5. So c will be equal to 1 divided 1.5 and then sine inverse, right?
Yes, it's giving 41.7.
Okay.
Sine inverse 0.6.
Okay. So it is 41.7 round 3 to in figure 7.1, draw carefully without calculation the continuation of the ray through the prism and into the air. So we have to draw with the reference given in the diagram. So first of all, light is moving from rare to dense medium, and we know that when light enters with the same direction, or you can say that with perpendicular condition to the medium, like so light will move straight without bending, right?
Yes.
So first of all, light is moving just perpendicular to it. So it will move without any refraction over here, move like this. And what about the next process?
It will bend away from the medium. The normal.
Okay. So now we have to draw. So this is our normal line, and we already know the critical angle. So critical angle is equals to 42. So if this angle is greater than 40, the light will completely reflect into the prism, right?
Yes.
And what will be the angle over here if you want to calculate the angle? And if you measure with the help of protractor over here, so you will find that this angle will be greater than 42.
42.
Yes. So this angle is greater than 42. So it means that light will completely reflect internally with the same angle. So it will reflect in, and now it is moving towards the downward phase. And when it reaches the downward phase, so again we have to find out that either it is moving away from normal or towards normal, because now line is not moving perpendicular to the surface. There is some angle. So what will be the next direction of the light ray? Now,
Will it go straight?
actually this line is not straight. It was looking straight in the diagram, but it is moving slightly towards right hand side in this direction.
So
So,
will it move towards the normal?
so when light travel from dense to rare, so we know that in total internal reflection also, we use the concept of dense to rare medium. So when light moves from dense to rare, so light will away from normal, right?
Oh, yes.
So if you remember the concept of dense to rare, light will move away from normal. So now light is going to move away from normal. So that means the angle like this. Okay.
Okay.
And the angles mentioned in the diagram helps you to identify the, so this 30 and the opposite angle 30, and this angle represented over here. So it will be equal to 60, right? So it means that is greater than the critical angle, which is already mentioned. So that's why we reflect the light internally into the prism. Okay, question number 3 is related to the convex lens. Figure 7.1 represents an object O placed in front of a converging lens. State a full description of the image I. So first of all, we need to identify either it is real or inverted. Sorry, real or virtual.
Virtual?
Yes, because it is on the same side, or you can say that on the back side of the object. So no image on the, it means that image is virtual, right?
Yes.
And what will be the next property?
Enlarged
Enlarge, yes,
and upright.
yes. So there are multiple options to write in this answer: virtual, enlarged, upright, or you can also write highly magnified. It's up to you. And using the latter on figure 7.1, identify the focal length of the lens. So what will be the focal length? Yes, you need to find out the focal length.
Q and R?
Q and R. Okay, so if you remember, when we draw a ray diagram for the convex lens, so we know that when parallel light or the light ray which is parallel to principal axis, so light parallel to principal axis after passing through the convex lens, it will bend through the principal focus. So this is the parallel light ray which is passing through the convex lens, and when it bends or it passes through the principal axis, so this point is known as the principal focus, right?
Okay.
And RS will be focal length, right? This will be the focal length. Okay,
Yes.
so this is the answer, and according to the length, RS gives you the focal length, right? Okay, on figure 7.1, draw an eye suitably placed to view the image. Now we have to place an eye in this diagram from where we can observe the object. So we know that we have to place the eye on the right hand side, and the second part figure shows an object placed to the left of a converging lens. A principal focus of the lens is at the position marked F. On figure 7.2, draw two rays to locate the image of the object O. Draw the image. Draw one other ray from the upper tip of O to the image. Okay, so we have to draw two rays to locate the image of the object, and we also draw the image. On figure 7.2, draw one other ray from the upper tip O to the image. So first we need to draw two lines, right? Then we have to add an other line. Okay, so we know that we have to draw first ray like this. So one ray will move to the principal axis and it will pass through the principal focus, right? And the second ray will pass from which position?
From the center?
Yes, from the center, that is optical center, this point. Actually, I am drawing freehand, so it may be some. So if we draw with a regular, so that will give you a clear image or the accurate image. Now I am drawing with freehand, so that's why I'll be irregular. But you will get the idea that how we are going to draw the image, and both line will intersect, and now we can easily draw the image on right hand side, and that will be the image of an object over here. So this is the image, right? That is inverted because we know that convex lens will produce inverted image. And now we have to draw one other ray from the upper tip of O to the image. So the third possible ray will be the opposite of the, just like this. The third ray will pass from the, so let's suppose we have to draw the focus on left hand side. So light ray will pass from the focus and then it will move parallel, right? like this. So this will be the third wave.
Okay.
So we are having rays over here, and these three rays are the standard rays which we need to remember. So always remember these three rays. If they ask about the image formation, so these rays or the formation of these three rays will be same everywhere in the convex lens, right?
Okay.
So question number 4, the refractive index of the glass is in air 1.5. State the equation to that relates the speed of light in air, the speed of light in glass, and n. So that is simple. What is the equation?
N equals VA divided by VG.
Yes. The formula of refractive index, that is V n is equals to the light divided by speed of, and we need to calculate the speed of light in glass. So we need to use the same formula again, right? That is to G equals to n. So that will be equal to 2
2
into.
times 10 to the power 8.
And if you observe that we are doing a third question of refractive index and they are asking about the same value, so that is 2 into 10 to the power 8. So this value is constant, right? Because the
Yes.
refractive index of the glass is 1.5, the speed of light remains constant. So it means this value will also remains constant. So that will help you to remember the answer. So we just need to cross check by calculating that either we are getting the same answer or not. And now light is traveling in the glass, strikes the edge of the glass, shows a ray of light at an angle 41. The light passes from the glass into the air. Calculate the angle that the ray makes with normal in the air. So now light is passing from glass to air. And what is the refractive index? Sorry, we need to first know about the critical angle and calculate the angle that makes the ray with the normal in the air. So which formula will help you to find out angle? N is equal to,
Sine I over sine R?
so we have to calculate the refractive angle, right? And since light is moving from dense to rare, so we know that when light moves from dense to rare, so of refraction divided sine angle of incidence, right? So sine angle will be equal to times plus 41.
I'm getting 79.
Final answer.
Yes.
So 7 degrees. State what happens to light that strikes the edge of the glass at an angle to the normal much larger than 41. So if light is with the angle greater than the 41, so what happens with the light that strikes the edge of the glass?
Total internal reflection?
Complete or partially?
Partial?
Yes. So because they are not mentioned this exact statement that it is equal to critical angle or greater than critical angle. So we can say that some it will reflect and some will refract. indication, multiple in classroom. Okay.
Yes.
Okay, so you may join back, then we will continue with the remaining questions, right?
Okay.